Hello students, straight back again. Today, notes for section 2.2, scientific notation and dimensional analysis. Your objectives, so you're going to complete this section. You should be able to express numbers in scientific notation, and you should be able to convert between units. Two big things we're going to do in this section. With Hummer notes, you've already done some of this. Yeah, just add anything else you need. Everything can be used on a quiz. Good review vocab term here. You need to know what quantitative data is, numerical information, how big, how little, how small, etc. Along with that, you should know what qualitative data is, just a general description, usually not involving numbers. Just 3 new vocab terms you're going to come along to. Your main idea for this section: we express numbers in scientific notation and solve problems using dimensional analysis. So scientific notation has to be a number between 1 and 10. That means it's always going to be a something single-digit decimal point, and that's a non-zero signal digit. So it's always 1 point, 2 point, 3 point, or so on up to 9 point. Never 10 point, 11 point, 100 point. Those are not scientific notation. Then multiplied by 10 raised to a power, known as the exponent. And I'll be using terms exponent and coefficient. So, there's a scientific notation: 4.6 times 10 to the 23rd. 4.6 is the coefficient, 23 is the exponent. Number of carbons in the carbon atoms in the Hope diamond. This slide gives us a general idea of how to switch between scientific notation and standard notation. So you should have seen this a lot in previous classes, so shouldn't be a big problem. But here's a couple examples down here. We'll do some more in class, but 800 is 8.0 times 10 to the second. Just one of the key things to remember is if you have a positive exponent means you got a big number. You got a negative exponent, meaning you got a small number. Really small number. Those are always 0 point numbers. Such as this one is 3.43 times 10 to the negative fifth. On these 0 point ones, you might notice you got a negative fifth here, got 5 zeros here. Addition and subtraction. We're going to be working, as we go through some stuff in class, we'll be working with adding and subtracting scientific notation numbers. But the key when you add and subtract, your exponents need to be the same. You also have to have the same units. If you don't have the exponents the same or rewrite them to make them the same, then you just add or subtract the coefficients and keep the exponent. Yeah, we'll be doing some examples in class, but that's the key thing to remember, is your exponents must be the same. Multiplication, division, key things here to remember: to multiply, you're going to multiply the coefficients and add the exponents. Divide, and divide the coefficients and subtract the exponents. Now, when we get done, we may have to do some adjustments on these. Dimensional analysis. We'll be doing a lot of work with dimensional analysis through chemistry. There's a nice definition and a definition of a conversion factor. Make sure you write those down. Conversion factors derive from equal relationships, like a dozen eggs is 12 eggs. Other things, we can use percentages as conversion factors. Also things like density can be a conversion factor, you know. Anything. Speed can be a conversion factor. Lots of things can be conversion factors. We use a lot of different things. Here's a little example, and this, again, as I do these, we can see I'm going to have a big long bar here, and then it's going to look like that. But we go through and we cancel out things like people cancel out persons, bottles cancel out bottles, and we do some multiplying and dividing. Couple quick review questions. Systematic approach converts from one unit to another. Dimensional analysis. We use conversion factors to accomplish our conversion ratio. These actually kind of mean the same thing. Scientific notation is just how we typically express our answers. Correct scientific notation. They're all 9.64, so that's good. This one's the one that you should notice obviously is wrong. It's 6 to something. It's always got to be 10 to something. This is a kind of a common mistake here on A because there's 4 zeros. We put a 4, but it's 3 6 decimal places is why it's the 6, not a 5, not a 4. So, just a quick overview of this lesson, adding anything else in your notes you want to have in besides what you already got with the Hummer. So that's it for now. We'll be back again.